Hi, this is Alex from devstories.eu. Biopython Fundamentals, episode 14 of 18. GeneBank is great when you are working with nucleic acids, but when you need expertly curated, hand-reviewed data on a protein, like its exact active sites or where it crosses a cell membrane, standard sequence databases fall short. You need a specialized protein database, and that brings us to Swiss-Prot and ExPASy integration. Swiss-Prot is a high-quality, manually annotated protein sequence database. ExPASy is the server portal that provides access to it. Biopython connects these two pieces. It uses the ExPASy module to download the data over the internet and the Swiss-Prot module to parse it into a structured object. First, you need to pull the raw record from the internet. You do this using the ExPASy module, specifically a function called getSprot_raw. You pass it a Swiss-Prot accession ID. For example, if you want the record for the human hemoglobin subunit alpha, you pass its accession ID, which is P69905. Calling getSprot_raw with this ID opens a network connection to the server and returns a handle to the raw text data. Once you have that raw text handle, you hand it off to the Swiss-Prot module. You call the read function and pass in your handle. This parses the flat file and returns a Swiss-Prot record object. Here is the key insight. This record object is not just a sequence string. It is a deeply structured container of expert metadata. Because Swiss-Prot is manually curated, the fields on this object are exceptionally rich. You can access the organism attribute to confirm exactly which species the protein belongs to. You can check the sequence length attribute to get the amino acid count instantly without needing to measure the sequence string yourself. The most valuable part of the record is the features attribute. This is a nested list containing the known structural and functional domains of the protein. When you iterate through these features, you will find specific annotations. You will see features detailing the exact amino acid coordinates for active sites, metal binding regions, or transmembrane domains. Instead of running a prediction algorithm, you are reading definitive, laboratory-confirmed coordinates straight from a curated database. In practice, your code flow looks like this. You call the getSprot_raw function from ExPASy with your accession ID. You take the resulting handle and pass it into the read function from Swiss-Prot. This gives you your record object. From there, you can read the organism, check the sequence length, or loop through the features list to extract the functional sites. Always remember to close the network handle once you are done reading the data to free up system resources. When you're building pipelines that rely on biological function rather than just sequence similarity, targeting Swiss-Prot guarantees you are basing your logic on verified, human-curated data. That's all for this one. Thanks for listening and keep building.